Begin with the Webb's beautiful observation of Cassiopeia A, a supernova remnant taken in April. For context, a supernova is the biggest explosion we know of. At the end of a star's lifetime, once it's exhausted its fuel supplies, there's no more outward pressure from fusion. As such, the star experiences a sudden gravitational collapse and violently explodes. What's left over depends on the size of the star, and can be either a neutron star, a black hole, or, in this scenario, a dazzling nebula of gas. These spectacular images of Cas A bring a fresh insight into the complexity of supernova remnant structures, and show us how intricate they really are. Cas A exploded roughly 340 years ago from Earth's frame of reference. It lies about 11,000 light-years away and is around 10 light-years wide. Researcher Danny Milisalvovich of Purdue University, Indiana, who worked on the images, said this is our best opportunity to, quote, run a kind of stellar autopsy to understand what type of star was there beforehand and how that star exploded. Webb's incredible tech has revealed new details about such processes, which were previously impossible to know. One key feature of this image is the semicircle of red and orange material along the top. This arises from interactions between ejected supernova debris and neighboring circumstellar material. A vibrant, luminous pink ring can also be seen in the photo. It's caused by heavy elements such as oxygen and neon, which were dispelled from the star itself. Not everything is known about what's going on here, however, as there is a mysterious and unexpected green loop in the central cavity as well. Astronomers are currently scratching their heads at this and have nicknamed it the Green Monster, after the left field wall at Fenway Park, a famous baseball stadium in Boston. These aren't the only remnants of a once vibrant star to capture the attention of Webb in 2023, though, as it also imaged the popular and well-studied Crab Nebula in October. The nebula lies 6,500 light-years away in the constellation of Taurus and, amazingly, was first recorded in 1054 AD by Chinese and Japanese astronomers. At the time, it wasn't the nebula itself they observed, but the explosion that birthed it, when it was visible for a whole 2 years and could even be seen during the day. Fast forward to now, and while in these recent images it bears little resemblance to a crab, we are able to accurately determine the composition of what remains, thus revealing new information about the type of explosion and star that came before it. In the center, creamy smoke trails are visible. This hasn't appeared so clearly in prior observations, and has now been explained as arising due to synchrotron radiation. This is radiation that's emitted from charged particles moving along curved paths at extremely high speeds. The cause of this is a pulsar lying at the nebula's heart, which is essentially a neutron star spinning extremely fast. In Webb's image, you can actually see where this pulsar resides, from the circular patterns created by the wisps of gas in the center. Never before has an object like this been photographed in such incredible detail, although it's likely we still have much more to learn. Next up, let's look at Webb's stunning photo of the famous Ring Nebula, taken in August 2023. Also known as M57, this object is a planetary nebula lying roughly 2,500 light-years away from Earth. It's rather close to us in the grand scheme of things, as, for comparison, the Milky Way is roughly 100,000 light-years in diameter. Contrary to what you might assume by its planetary descriptor, the Ring Nebula actually isn't linked to a planet. Planetary nebulae are created from old dying stars late in the stages of stellar evolution. Specifically, they're red giant stars, which have depleted the majority of their core hydrogen needed to fuel fusion. Instead, fusion will begin on the outer edges of the star's core. This means the core will contract and get warmer, whereas the outer layers will do the opposite. And during this phase, massive quantities of gas are thrown from its outer layers. At the same time, the contracting core will start to radiate large amounts of energy, which ionizes the outer layers on their way out. This ionization is then what causes the vibrant colors seen in Webb's image. We can also see soaring arcs surrounding the Ring Nebula, which imply the existence of a low-mass companion somewhere orbiting the dying star. It's another image that truly opens our eyes to the complexity and balance of space. Number 4. And while Webb is more than capable of seeing distant stars, it's also well equipped to look a bit closer to home. In February, it took the most successful images of Uranus ever produced. Webb's shots are a stunning contrast to earlier images taken in 1986 by Voyager 2, in which the atmosphere of Uranus appeared to be bland with a lack of noteworthy features. Here we see that isn't the case. A year earlier, in 2022, Webb also captured breathtaking images of the planets Jupiter and Neptune, in particular showcasing Neptune's rings with never-before-seen clarity. The new photos of Uranus reveal similarly sparkling features about its neighboring ice giant, displaying another magnificent system of rings in orbit. Uranus shines brightly with a spectacular blue glow. Its polar cap can also be seen clearly, being the white circle on the right side of the image. Usually, ice caps are at the top and bottom of planets. However, Uranus is peculiar in its rotation. While Earth rotates about an axis tilted roughly 23 degrees, Uranus's axis of rotation is an impressive 97 degrees. This means its rotation is almost perpendicular to its plane of orbit, giving it these unique sideways poles. As such, the planet is thought to possess an extremely dynamic and harsh atmosphere, with a year on Uranus being 84 times what a year on Earth is, implying seasons that last at least 2 decades. Finally, and again in August, Webb took images of the galaxy cluster El Gordo, or the Fat One. It's located more than 7 billion light-years away from Earth, and its mass is roughly 2.1 quadrillion times the mass of our Sun, making it the largest galaxy cluster we know of. It was formed 6.2 billion years after the Big Bang, making it also the oldest astronomical object in this video. Gravitational lensing is incredibly prominent here, an effect originally predicted by Einstein over a century ago. Gravitational lensing occurs from objects so exceedingly massive that they distort and magnify the light from objects behind them. This image includes multiple gravitationally distorted galaxies. It also clearly shows the hundreds of galaxies that call El Gordo their home. For example, El Anzuelo, or the fishhook, can be spotted in the top right corner of Webb's image. This is a bright red galaxy that appears curved or hooked. In actuality, its geometry is much less interesting, and it resembles that of a disk. But the curvature we see arises from El Gordo's strong gravitational potential, which distorts the light that reaches us. Just to the left of center, a long, thin line can be spotted stretching across the photo too. It's called La Flaca, or in English, the Thin One. Astronomers were also able to identify a red giant star called Koiler. This now holds the title of the most distantly observed red giant, alongside being the only red giant seen over 1 billion light-years away from Earth. Throughout 2023, the James Webb Space Telescope has provided us with some awe-inspiring and mind-boggling visualizations of space. With these, researchers are solving mysteries that were previously impossible. And with a further 10 years or more planned for the mission in total, there should be plenty more to watch out for in the future.